This is the sixth part of the chapter Volumetric Analysis, or you can say Redox reactions as per NCERT. And in this video, the solutions to the 20 questions given to you in the previous part of this chapter, that was the fifth part, have been discussed.
Hello and welcome my friends. Let me give you my brief introduction. मेरा नाम विक्रांत कुमार है. आई एम एन एजुकेशन कंसल्टेंट एंड केमिस्ट्री फैकल्टी फॉर IIT JEE एंड नीट. मैंने अपनी B.Tech केमिकल इंजीनियरिंग में IIT बॉम्बे से की. IIT JEE की प्रिपरेशन मैंने सुपर 30 से की थी एंड माय ऑल इंडिया रैंक इन IIT JEE वाज 869. So in this video we are going to learn the solution of the questions asked to you in the previous video, which was based on the calculation of n factor for the substances involved in redox reactions. I'll remind you just some parts of that video that we had learned कि n factor of the substances in redox reaction कैसे calculate किया जाए. तो एक जो fundamental method था, that method was telling us कि balance the reaction and then the number of electrons involved divided by the stoichiometric coefficient of the reactant or product involved will be its n factor. So that was the fundamental method. लेकिन if you remember कि केस A, केस B and केस C ऐसे तीन केसेज हम लोगों ने सीखे थे जिसमें you don't have to balance the reaction actually to get the n factor of a particular substance. So ऐसे ही केसेस से रिलेटेड हम लोगों ने कुछ क्वेश्चंस देखे थे. तो मैंने आपको केस ए के बाद 15 क्वेश्चंस दिए थे एंड केस बी के बाद मैंने आपको 5 क्वेश्चंस दिए थे. तो वी आर गोइंग टू सॉल्व दोज क्वेश्चंस कि उनके सॉल्यूशंस क्या है. आई होप कि आप लोगों ने उसको सॉल्व कर लिया होगा. अगर नहीं किया है तो फिर से उस वीडियो को देखकर एक बार उसको सॉल्व कर लीजिए एंड देन कम टू दिस वीडियो सो दैट आपको एक कॉन्फिडेंस आएगा कि यू कैन सॉल्व दोज क्वेश्चंस बाय योरसेल्फ आफ्टर लर्निंग द मेथड्स. ठीक है, तो अभी मैं इसको सॉल्व करना स्टार्ट कर रहा हूं. सो लेट्स सी. ये केस ए के बाद मैंने आपको 15 क्वेश्चंस दिए थे. उन सारे क्वेश्चंस के सॉल्यूशन देखते हैं. तो मैंने पूरा रेडॉक्स रिएक्शन नहीं दिया था आपको. मैंने सिर्फ एक साइड में एक रिएक्टेंट और दूसरे साइड में एक या दो प्रोडक्ट दिए थे. मतलब हम लोगों ने ऐसा मान लिया था कि इफ केस ए इज एप्लीकेबल फॉर द गिवन सब्सटेंसेज इन द फॉलोइंग ट्रांजिशंस. तो ऐसा अगर एप्लीकेबल मानते हुए फिर जाके अगर हम लोगों को एन फैक्टर इनके कैलकुलेट करना है तो क्या होंगे इनके एन फैक्टर. इफ यू सी द होल रिडॉक्स रिएक्शन, उसमें केस ए कैसे एप्लीकेबल है ये हम लोगों ने ऑलरेडी प्रीवियस वीडियो में सीखा है. सो उस चीज को अगर आप रिवाइज नहीं किए हैं तो उसको एक बार जाकर पढ़ के लर्न करके सीख लीजिए एंड देन वी विल सी द सॉल्यूशन. ठीक है, जिन लोगों ने उनको ऑलरेडी देख लिया, जिन लोगों ने ये क्वेश्चन सॉल्व कर लिए हैं, उन लोगों के लिए वीडियो है कि लेट्स सी कि क्या है राइट सॉल्यूशन इन क्वेश्चंस का. तो इफ यू सी KMnO4 गिविंग MnSO4, Mn is present in +7 oxidation state. On the left side, right side, it is present in +2 oxidation state. So per Mn change है 5 का. So अगर इसके n factor की बात की जाए, so if you are talking about the n factor of KMnO4, there is change of 5 per Mn and there is just one Mn. So that's why its n factor is 5. If you are talking about MnSO4, we are assuming that Mn only is changing its oxidation state while coming from left to right. Then its n factor will be 5 का change for each Mn. There is change of 5 for each Mn and there is just one Mn in MnSO4. That's why its n factor is also 5. So both are having n factor equals 5. Let's come to second question. In second question, we are having K2Cr2O7 giving CrCl3. So we are talking about Cr as the functional atom in both the compounds. So Cr here is in +6 oxidation state, here it is in +3 oxidation state. So now if these are the oxidation states, so there is change of 3 per Cr. So if you are talking about n factor of K2Cr2O7, change of 3 per Cr, and there are 2 Cr atoms, and that's why there is total change of 6. So its n factor is 6. If you're talking about CrCl3, n factor for CrCl3, there is change of 3 per Cr, but there is just one Cr, so its n factor is 3. Let's come to third question. In third question again, we'll see the oxidation states. Again, it is in +6 in K2Cr2O7. It is in +3 oxidation state in Cr2SO4 thrice. So again, there is change of 3 in terms of oxidation state per atom of Cr. So change of 3 per atom and there are 2 atoms. So n factor is 6. If you are talking about Cr2SO4 thrice, there is change of 3 per atom of Cr. So 3 ka change, but we are again having 2 Cr atoms here. So total change is 6. इफ यू आर टॉकिंग अबाउट फेरिक ऑक्सिलेट, इंपॉर्टेंट कंपाउंड्स ये सारे हैं, ये इंपॉर्टेंट ट्रांजिशंस हैं जो आपको बराबर दिखेंगे टाइट्रेशन के डिफरेंट क्वेश्चंस में. सो इसमें Fe जो है वो ऑलरेडी +3 में आ रहा है, दैट वी आर अज्यूमिंग, क्योंकि ये Fe ऑलरेडी +3 में है तो इसका कोई चेंज नहीं होने वाला है. सो वट एवर चेंज इज हैपनिंग हियर, इट इज अबाउट कार्बन. सो कार्बन वॉज इन +3, it is going in +4. So carbon is the functional atom. So considering carbon as the functional atom, here change of oxidation state is 1 per carbon. +3 to +4 there is change of 1. And that's why per carbon changes of 1, there are 6 carbon atoms. यहाँ पे mistake हो जाता है. So you need to be very careful. There are 6 carbon atoms. So 1 into 6 is 6. So N factor of ferric oxalate in redox reactions, if it is getting oxidized to give CO2 gas, will be 6. If you are talking about CO2 itself, its carbon is in +4 which is coming from +3, so there is change of 1 per carbon atom and it is having just 1 carbon atom, that's why its N factor is 1. If you talk about fifth question, now in case A also there can be two sub cases. One, if there is just one functional atom, one functional element, in other case there can be two functional elements. So question number 5 is of the other case, that is there are two functional atoms. Fe is in +2 here, Fe is in +3 here, carbon is here in +3, carbon here is in +4. So there are two functional atoms in FeC2O4 and that's why यहाँ पे दो मेथड की बात हम लोगों ने की थी, एक अल्टरनेट मेथड भी दिया था. दोनों मेथड से इसका सॉल्यूशन देखते हैं. फर्स्ट मेथड से देखते हैं. सो फर्स्ट मेथड वाज to check the total change in oxidation state one by one per atom. देखते हैं. So first method में if you are talking about N factor of FeC2O4, Fe is going from +2 to +3, so 1 का change for each Fe, there is just one Fe, plus there are two carbon atoms, each is going from +3 to +4, so 1 का change for each carbon and there are two carbon atoms, so its N factor is 3. That is the first method. Second method, what will be the second method? So as per the second method, we need to see the total summation of oxidation state of all the atoms involved in the substance on the other side. See it very carefully. It is the total summation of oxidation state of the atoms given in the compound on the other side. So Fe on the other side, there is just one Fe here, and on the other side Fe is in +3. So +3 into 1. Plus there are two carbon atoms and both are in +4 oxidation state, so +4 into 2 because there are two carbon atoms in this substance, plus oxygen on the other side is obviously in -2 and there are 4 oxygen atoms, so this one minus total charge on the given substance, so total charge here is 0. So that's why if you add these things, 3 plus 8 minus 8 minus 0, and that is 3 only. So both the methods are giving you the same answer. Sometimes this method is easier, sometimes this method is easier. We'll see. In this case, this method is looking easier, but you will see some cases in which the second method will look easier to you. If you are talking about Fe3 plus here, Fe3 plus is coming from Fe2 plus, so +2 to +3 there is change of 1 per Fe and there is just one Fe, so its N factor is 1. If you are talking about CO2, CO2 में carbon is in +4 oxidation state which is coming from +3 and that's why change is of 1 per carbon atom and there is just one carbon atom in CO2, so N factor is 1. So these were the first 5 questions related to case A. Let's come to question number 6. So in question number 6, PbO, in PbO, Pb is in +2, in Pb3O4, Pb is in +8/3. We had learnt it in the first lecture itself, first video itself, that Pb, there are two forms of Pb, +2 as well as +4, and that's why it is a mixed oxide in which average oxidation state is +8/3. And that's why if you want to talk about N factor, Pb is going from +2 to +8/3, there is change of 2/3 per Pb atom. So change of 2/3 per Pb atom and there is just one Pb here and that's why its N factor is 2/3. Again we can get fractional N factor and that can too be less than 1 in some cases. So this is one of the example in which we are getting a fractional N factor and that too is less than 1. So in this case, molecular weight will be even less than the equivalent weight. If you are talking about Pb3O4, again we have change of oxidation state 2 by 3 per Pb atom, and there are 3 Pb atoms, so its N factor is 2. So that's the solution of question number 6. Let's come to the question number 7. In question number 7, again we need to be very careful. We are talking about the average oxidation state because again this is a mixed oxide. So here the average oxidation state is plus 2 by 0.95. Here the oxidation state of each Fe is plus 3. So per Fe change is of 3 minus 2 upon 0.95. This is change per Fe and there are 0.95 Fe. So basically here if you calculate it, what you are getting, it is 2.85 minus 2. So this is 0.85. That is the N factor of Fe 0.950 in the question number 7. If you are talking about Fe2O3, N factor will be again change per Fe atom is same 3 minus 2 by 0.95, but this time we have 2 Fe atoms. So this number is, this is 2.85 minus 2 by 0.95 into 2. So that is 0.85 ka double 1.7 by 0.95. You can solve this. If you are talking about question number 8, Zn was in 0 oxidation state. Here is it is in plus 2. So N factor is change per Zn atom is 2 and there is just one Zn atom, so its N factor is 2. Similarly in question number 8, ZnSO4 change per Zn atom is 2 again and there is just one Zn atom, so N factor is 2 again. If you are talking about this compound, I2, in I2 I is in 0 oxidation state, IO4 mein I is in plus 7 oxidation state, and that's why change per I atom is of 7 and there are 2 atoms here, so N factor is 14. But if you are talking about IO4 minus, change per iodine atom is 7 but there is just one I atom, so its N factor is 7 itself. If you are talking about, this is called thiosulfate ion, this is called tetrathionate. So in this average oxidation state is plus 2 and here average oxidation state is plus 2.5. If you remember the first video in which we had talked about the oxidation states, there are 4 sulfur atoms and 2 are in plus 5 and the remaining 2 are in 0 oxidation states. But here we can use the average oxidation state which will be coming plus 2.5. So for average oxidation states, if you are talking about, so per sulfur change is of 0.5. So if you are talking about N factor, per sulfur change is of 0.5 and there are 2 sulfur atoms, so its N factor is 1. This is important transition. You will see that in iodometric and iodimetric titrations में इसका use करेंगे हम लोग बहुत ही frequently. Similarly, if you are talking about N factor for S4O6 2 minus, change per sulfur atom is of 0.5 and there are 4 sulfur atoms, so total change is 2, and that's why N factor of S4O6 2 minus is 2 in question number 10. Let's talk about question number 11. In 11 again we have thiosulfate, but this time it is in the form of a neutral molecule. So this is sodium thiosulfate, again very important compound. जैसा मैंने बताया thiosulfate ion was there. Normally it will be in the form of molecule. So generally we take sodium thiosulfate. Na2H2O3 is the formula of sodium thiosulfate. If you are talking about something called hypo, it is nothing but Na2H2O3.5H2O. दिस इज एन इंपॉर्टेंट रिएजेंट, इसकी बात हम लोग आगे करेंगे. यहाँ मैंने आपको 2 ट्रांजिशन दिया. अभी जस्ट पिछले क्वेश्चन में हम लोगों ने बात की दैट थायोसल्फेट वाज गोइंग इन टेट्राथायोनेट आयन S4O6 2 minus. This time we are converting it into sulfate ion. So it depends on the medium. The behavior of Na2H2O3 will be different. If it is acidic medium, it will be going in the form of Na2S4O6, which is the by default medium. If nothing is written, we consider acidic medium. But if basic medium is given, that gets converted into sodium sulfate. And that's why it will have different N factor in different compounds, and which is an important fact you are supposed to know. So in next lecture, you will see that we'll be talking about some important compounds when we are entering into simple titration, and then we'll move forward with the remaining type of titrations. So when we are talking about sodium thiosulfate, again we have already learned that its oxidation state of sulfur in the compound is +2. Here it is in +6. So change per sulfur atom is of 4 and there are 2 sulfur atoms. So here its N factor is 8. If you remember in the previous question that N factor of Na2H2O3 will be 1 only. Here it is 8. If you are talking about N factor of Na2SO4, +6 to +2, change is of 4 per sulfur atom. There is just 1 sulfur atom. So N factor is 4. Let's talk about question number 12. In question number 12, this is in +3, I is in -I. If you see, chromium here is in +6, iodine here is in +7. Again, this is case A because multiple functional atoms are there. Both are getting oxidized. So again, there are two methods. Let's see this example by both the methods as far as the CRI3 is concerned. So the first method says take each individual functional atom and add the total change in oxidation states. So for chromium, it is going from +3 to +6. Change per chromium atom is of 3 and there is just 1 chromium atom. So 3 into 1 plus. Iodine is in -1. It is going in +7. So change is of 8 per iodine atom and there are 3 iodine atoms. So this is 8 into 3, 24 plus 3, 27. Let's see it by the other method. What is other method? In that we see all the atoms will have some oxidation state on other side. So add all those oxidation states for each atom involved in the given compound. So there is 1 chromium which is on the other side in +6 oxidation state. So we write +6 into 1. Why we are writing 1? Because the compound which we are talking about is having just 1 chromium. So we are taking oxidation state from the another side, number of atom from the compound which we are talking about. So +6 into 1 plus iodine on the other side is in +7 oxidation state, but we have just 3 iodine atoms here. So we are writing this one minus the total charge on the given compound जिसकी बात हम लोग कर रहे हैं, जिसके n factor को निकालने की कोशिश कर रहे हैं. If it is a neutral molecule, the total charge is 0. And that's why when you add again you are getting 27. So both the methods are applicable. You choose your as per your convenience which method you want to use. So now if you are talking about Cr2O7 2-, there is just one functional atom which is chromium, and that's why its N factor is change per chromium atom is of 3 +6 2 +3. So change per chromium atom is 3 and there are 2 chromium atoms, so 6. It is the first method which we are talking about. So if you are talking about IO4-, iodine is coming from -1 to 7. So change per iodine atom is of 8 into there is just one iodine atom in IO4-, so this is 8. So that is the 12th example. So these are the solutions of 12th question. So let's come to 13th. If you remember last video में हम लोगों ने इस example को discuss किया था from both the methods. I'll just repeat it again. PB is in +2, I is in -1/3. PB here is in +4, here I is in +7. So if you are talking about n factor of this, let's solve it by the second method. So PB on the other side is in +4. So +4 into 1 plus there are 6 iodine atoms and iodine is on the other side is in +7. So +7 into 6, there are 6 iodine atoms minus the total charge of this compound is 0. So if you add these things you are getting 46. So that is the net N factor of PbI3 twice. Now you can solve it by the first method itself. For each PB there is change of 2. So you can also write 2 into, I'm talking about the first method which we are using frequently. So 2 into 1 plus, here it is little bit complicated that each iodine is in -1/3, it is going in +7. So the change is of 22/3 per iodine and into 6. Again you are getting 46. So that is the first method. कोई भी एक method use कर सकते हैं आप लोग. PbO2 की बात करें, PB is coming from +2. So that's why net change will be per iodine changes of 2. There is just one PB, so net change is also 2. So 2 is the N factor of PbO2. If you are talking about IO4-, so for IO4-, each iodine is coming from -1/3 to 7. So there is change of 22/3 per iodine and there is just one iodine. So again we are getting fractional N factor here. Question number 14. Again, this is fool's gold. This is in this compound, Fe is in +2, sulfur is in -1. This is like peroxide is having O2 2 minus, each oxygen is in -1 oxidation state. Similarly, this is persulfide. And that's why if you're talking about N factor, let's apply again the second method. In these type of compounds, second method looks easier generally. But it is again as per your convenience, you can choose any method. So Fe on the other side is in +3 oxidation state, and we have just one Fe in this compound, plus sulfur on the other side is in +4 oxidation state, and we have 2 sulfur atoms, minus total charge is 0. That's why we are getting 8 plus 3 11. You can apply the first method also. Let's apply that quickly. Fe is going from +2 to +3, so change is of 1 per Fe, and there is just one Fe, and each sulfur is going from -1 to +4, so change per sulfur is 5 into there are 2 sulfur atoms. So again 5 into 2 10 plus 1 is 11. So we are getting again 11 as the N factor. So दोनों मेथड यूज कर सकते हैं, कोई भी देख लीजिए आप, या फिर कभी कभी तो दोनों मेथड से करके देख लेते हैं, कंफर्म कर लेते हैं आर वी गेटिंग द सेम आंसर और नॉट. सो दैट गिव्स यू कॉन्फिडेंस कि नहीं दोनों मेथड से सेम आंसर आ रहा है, इट इज राइट. So if you are talking about Fe2O3 in this compound, in this reaction, so Fe is coming from +2 to +3, 1 ka change for each Fe, and there are 2 Fe, so that's why its N factor is 2. If you are talking SO2, S is in +4, which is coming from -1, so for each sulfur there is change of 5, and there is just one sulfur here, so that's why N factor is 5. Let's talk about the question number 15, which is the last question of case A. So in this case also again As is in +3, sulfur is in -2. Now As is going in the +5 oxidation state, sulfur is going in +6. Again you can apply both the methods for this compound. Generally if there is just one functional element, in case A just apply the first method, that is easier one. But if you are having multiple functional elements, you can also apply second method. I personally prefer second method only when there are multiple functional element. But in any case, you can apply any method. So if you are talking about the first method, let's do it with both the methods. So +3 to +5, 2 ka change for each arsenic, and there are 2 arsenic. So 2 into 2. Sulfur -2 to +6. Change of 8 per sulfur atom, and there are 3 sulfur atoms, so 24 plus 4, this is 28. Let's apply the second method. Arsenic on the other side is in +5 oxidation state, and we have just 2 arsenic atoms, plus sulfur on the other side is in +6 oxidation states, and we have 3 sulfur atoms, minus total charge on S2S3 is 0, and that's why 10 plus 18, that is 28. Again we are getting the same answer, so that gives us the confirmation as well as confidence that I can solve the question by both the methods. Again for ASO3 minus N factor, arsenic is coming from +3 to +5, so change per atom is 2, and there is just one arsenic atom here, so N factor for this compound is 2. If you are talking about sulfate ion, sulfur is coming from -2 to +6, so change is of 8 per sulfur atom, and there is just one sulfur atom, so total N factor is 8. Again remember the mistake sometimes happens when we are saying कि -2 to +6 how much is the change. So कभी कभी दिमाग में आता है 2 is there, 6 is there, so change is of 4. Always remember -2 प्लस जा रहा है, तो you have to see कि कितने का चेंज हो गया है. तो बिगर नंबर माइनस स्मॉलर नंबर करना है, तो +6 minus -2 will give you +6 plus 2, and that is of 8. And that's why in these cases just be slightly more careful. So these were the 15 questions based on the case A. Let's see the remaining 5 questions which I had given you after case B. These were the questions given to you after case B in the previous video, जिसमें हम लोगों ने N factor for redox reactions discuss किया था. तो what was case B? I'll just remind you again. केस बी में हम लोगों ने देखा था अगर कोई सब्सटेंस ऑन द अदर साइड डिसप्रोपोर्शनेट होता हुआ जाता है. डिसप्रोपोर्शनेट होता हुआ का मतलब सेम एलिमेंट इज अंडरगोइंग ऑक्सीडेशन एज वेल एज रिडक्शन. In that case, we had a formula for the substance which is undergoing disproportionation. उसके N factor के लिए अपने पास एक formula था. What was that formula? that formula was N1 into N2 divided by N1 plus N2. What was N1 and what was N2? N1 is the N factor with respect to oxidation only and N2 is the N factor with respect to reduction only. हाँ, ये यहाँ पर ये बात ध्यान में रखिएगा कि वही सब्सटेंस ऑक्सीडाइज भी हो रहा है, रिड्यूस भी हो रहा है और कोई दूसरा सब्सटेंस जो है वो अपना ऑक्सीडेशन स्टेट चेंज ना कर ले फिर, तो ये ध्यान में रखना पड़ेगा. ये चारों रिएक्शंस क्या है, नॉन मेटल के रिएक्शंस NaOH के साथ अगर होते तो हम लोग कहते हैं जनरली दे आर अंडरगोइंग डिसप्रोपोर्शनेशन एक्सेप्ट F2 कैन नॉट बी डिसप्रोपोर्शनेटेड एट ऑल. व्हाई? बिकॉज F2 में F इज इन जीरो, इट कैन नेवर गो टू पॉजिटिव ऑक्सीडेशन स्टेट. वो या तो जीरो में होता है या फिर -1 में होता है, हमेशा रिड्यूस होने के लिए जाता है बिकॉज F इज द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट एंड दैट्स व्हाई F2 विल नेवर बी अंडरगोइंग डिसप्रोपोर्शनेशन. एक एक करके देखते हैं यहां जो रिएक्शंस दिए हुए थे इनमें क्या करना है. सो द सब्सटेंस विच इज गेटिंग डिसप्रोपोर्शनेटेड हेयर इज इन द क्वेश्चन 1 इज Cl2. कैसे डिसप्रोपोर्शनेट हो रहा है, वो जीरो ऑक्सीडेशन स्टेट के साथ था, इस साइड में वो -1 में भी जा रहा है और +1 में भी जा रहा है. सो दैट्स व्हाई 0 से -1 जाना रिडक्शन, 0 से +1 जाना ऑक्सीडेशन. NaOH में किसी भी एक एलिमेंट का कोई भी ऑक्सीडेशन या रिडक्शन नहीं हो रहा है. Na+1 यहां भी +1 में है, O-2 यहां भी -2 में ही है, H+1 यहां भी +1 में ही है. So NaOH is not undergoing any change in oxidation state but Cl2 is getting disproportionated. तो इसके लिए अगर मेरे को N1 N2 मिल जाए तो हम लोग N फैक्टर निकाल देंगे. तो what is N1? N1 is N फैक्टर with respect to oxidation only. Oxidation का मतलब 0 से 1 जाना, +1 जाना में 1 का change for each chlorine there are 2 chlorine atoms. So N factor with respect to oxidation only is 2. If you are talking about N2 will be N factor with respect to reduction only. Again 0 से -1 जाना is also 1 का change for each chlorine and there are 2 chlorine atoms. So 1 का change for each chlorine atom into 2. So that's why this is also 2. So that's why N factor अगर पूछे, what is the N factor of Cl2 here? It will be 2 into 2 by 2 plus 2. And that is 4 by 4 which is 1. So N factor of Cl2 in this reaction is 1. Similarly we'll go to next one. So now this reaction was in cold and dilute NaOH. If you are taking hot and concentrated NaOH, the product will be, one of the product will be same NaCl here but the other product will be NaClO3 and that's why N factor of Cl2 will change depending on the condition which you are creating. So here it was in 0, here it is in -1, here it is in +5. And that's why for Cl2 what is N1, that is N factor with respect to oxidation only. So 0 to +5, 5 ka change of 5 per Cl atom and there are 2 Cl atoms, so 10 is the N1. If you are talking about N2, what is N2? N2 is N factor with respect to reduction only. 0 to -1 change of 1 per Cl atom, so change of 1 per Cl atom, there are 2 Cl, so 2, and that's why N factor of Cl2 will become 10 into 2 divided by 10 plus 2, that is 20 by 12, or you can say 5 upon 3. That is fractional N factor. Now next reaction, sulfur, it is in 0. Now you need to take care, is it S or S8? That will give you different numbers for the N factor. So here we are talking about S only. You can also write S8, then you have to see कि into 8 करना पड़ेगा हर बार जो भी N factor यहाँ आने वाला है, because there are 8 atoms in S8. So 0 to -2, here in sulfide it is -2, here in Na2S23 which was called sodium thiosulfate in which it is in +2. तो 0 to +2, N1 is 2 का change per S atom and there is just 1 atom, so 2. Similarly N2, that is N factor with respect to reduction only, so 0 to -2, again change of 2 per sulfur atom, there is just 1 atom, so N2 is also 2. So similarly, similar to the Cl2 in the first case, N factor of sulfur S will be 2 into 2 by 2 plus 2 and that is 1. So that is the answer for question number 3. Let's come to the fourth question in which P4 was undergoing disproportionation. In P4 there is 0 oxidation state of each phosphorus atom. Here it is -3. In this case if you see this is +1, you can check that also, Na is +1, H is +1, so phosphorus will be +1 and that's how you are having 4 atoms with +1 and there are 2 oxygen atoms with -2. So +4 and -4 will be 0. So phosphorus is here is in +1 oxidation state. Now just see N1. What is N1? N1 is N factor with respect to oxidation only, and that's why 0 to +1 change of 1 per phosphorus, but here there are 4 phosphorus atoms, so that's why 1 into 4, that is 4. And when we talk about N2, 0 to -3 change of 3 per phosphorus atoms, but there are 4 phosphorus atoms, so 3 into 4 is 12, and that's why N factor of P4 here will be 4 into 12 divided by 4 plus 12. So this is 48 by 16, which is 3. So 3 is the N factor of P4 in this case. So let's come to the last question of the day. So here again you need to see what is the oxidation state of phosphorus here. With the non-metals we take hydrogen will be having oxidation state of +1, and that's why it will be -2 oxidation state in P2H4. Here it is having -3. Here it is having -half. I'll write it here also, -3 -half, and here it is -2, and that's why when we calculate N1, which is N factor with respect to oxidation only, so -2 to -half is oxidation. So -2 to -half, what is the change? Change per atom is 3 by 2, that is 1.5. Into there are 2 phosphorus atoms, so into 2, so it is 3. But when we talk about N2, N2 is N factor with respect to reduction only. So with respect to reduction, it is going from -2 to -3, so there is change of 1 per phosphorus atom, and we have 2 phosphorus atoms, so 1 into 2, that is 2, and that's why N factor of P2H4 in this reaction is 3 into 2 by 3 plus 2, which is 6 by 5 or 1.2. Depending on the option, you can choose one option, either 6 by 5 or 1.2. So this was the last question given to you in the previous video as a homework. In the next video, we'll continue our chapter with the different type of titrations. I'll remind you there are several type of titrations, including simple titration, back titration, iodometric titration, iodimetric titration, and the last one is double titration. While covering this titration, when we'll enter into the simple titration, we'll see there are some important compounds for which some facts we are supposed to know, and that's why during that simple titration only we'll cover the important compounds, like what are the important compounds: KMnO4, K2Cr2O7, H2O2, oxalates, sodium thiosulfate. These are some important compounds. We can also cover some other compounds like oleum is there. It is SO3 gas compressed inside H2SO4. We can cover that part also. So mostly that will be the next topic, simple titration including important compounds, and then we'll move to back titration and other type of titrations in further videos.
दोस्तों उम्मीद करता हूं कि आपने इस वीडियो से काफी कुछ सीखा होगा और आपको ये वीडियो पसंद आया होगा। अगर हाँ तो YouTube पे इस वीडियो को लाइक कीजिए और अपने दोस्तों एंड फैमिली के साथ भी शेयर कीजिए। For the remaining videos of this chapter, follow the playlist of volumetric analysis and don't forget to subscribe my channel. Thank you and take care.